Myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about Cauchy Euler equation. This is a part of linear ordinary differential equation with constant coefficient. But this is not perfectly a linear ODE with constant coefficient. We have to, this is a specific type of ODE of higher order and first degree, but for solving these Cauchy Euler equations we have to reduce the Cauchy Euler equation to a linear ODE with constant coefficients. Then we solve that ODE using de operator method or method of variation of parameter. Okay, so in this chapter, mainly we have to know that Cauchy Euler equation, the general form of Cauchy Euler equation, and how Cauchy Euler equation can be reduced to linear ODE with constant coefficient. Okay, so the general form of Cauchy Euler equation is x square d square y dx square plus p1x dy dx plus p2y equal to capital X. Here you can see that the coefficients are not constants. In the previous chapters, previous videos, we dealt with the linear ODE with constant coefficients. But the Cauchy Euler equation is not an ODE with constant coefficients. The coefficients are variable. So the type of Cauchy Euler equation, that is how we can tell that the equation is Cauchy Euler equation. The rule is, you see always that the order of the differentiation is equal to the power of x. That is, here this is 2, here this is 2. Order of differentiation is 1, power of x is 1, no differentiation, no x. Okay, and you know that right hand side function capital X is a function of x. So this is the rule how you can tell that the ODE is a Cauchy Euler equation. Order of differentiation will be equal to the power of x. Now here I must say that always there will be only x, it is not mandatory. There may be any linear function of x, it may be x plus a or x minus a. Any linear function of x may be here. Okay, so rule is same, solution rule is same, so I am dealing with x. Okay, now first we have to transfer this equation to an ODE with constant coefficient. So for that, first I am assuming that let x equal to e to the power z. I am doing this substitution. Okay, then z will be log x. If there is any another linear function of x, in place of x if there is x plus or x minus a, then e to the power z will be put in place of x plus a or x minus a. Whatever may be the function here, that will be replaced by e to the power z. Okay. So z equal to log x, and differentiating both sides with respect to x, we get dz dx equal to 1 by x. Okay. Now we know that dy dx can be written as dy dz into dz dx by chain rule. You know this chain rule. You have learned in the chapter of functions of several variables, which was in the syllabus of first semester. So we are putting dy dz into the value of dz dx is 1 by x. Okay, dy dx equal to dy dz into 1 by x. Now by cross multiplication, x dy dx equal to dy dz. So you see that the value of x dy dx is dy dz. If we put the value of x dy dx here, then it will be p1 dy dz. So there will be no variable in the coefficient. the coefficient becomes constant. Next, we again differentiate this both sides with respect to x. So this will be dy dx plus x into d square y dx square equal to d square y dz square into dz dx, since we are differentiating with respect to x. Now dy dx plus x d square y dx square. Okay, I am putting here the value of dz dx value is 1 by x, so I am putting this value. Now we are multiplying by x, this x both sides, so it will be x dy dx, x square d square y dx square, and it will be d square y dz square. Okay, now x square d square y dx square will be x square d square y dx square will be d square y dz square minus x dy dx. I have transferred this into right hand side and I will put the value of x dy dx, which is dy dz. So this will be d square y dz square minus dy dz. I have put the value of x dy dx. So this is the value of x square d square y dx square, okay, which can be put here. Then you will see that there will be no variable in the coefficients. The equation will be converted into a linear ODE with constant coefficient, and the independent variable will be changed from x to z. Okay, now we will put these values in this equation. Now if we put, then it will be d square y dz square minus dy dz plus p1 x dy dx is dy dz plus p2y equal to x. So d square y dz square plus p1 minus 1 into dy dz plus p2y equal to x. So here you see that this equation is a ordinary differential equation, linear ODE with constant coefficient. Now you can solve this using D operator method or method of variation of parameter, which I have discussed in the previous videos. So the main thing is to convert the Cauchy Euler equation to this form. Then you will follow the procedure you have done previously. Okay. I will take an example. Before that, I will say that this conversion you will have to do in every sum of Cauchy Euler equation. But now I am doing a sum. I will not again repeat this conversion method. The value of x dy dx and the value of x square d square y dx square will be same for all sum, because this is not dependent on the given equation. This is dependent on the procedure substitution, and x equal to e to the power z. So since this will not be changed, though the value will be same for all equation. So these values are fixed, though you have to show this conversion procedure when you will do in your examination. Okay, now I am taking an example of Cauchy Euler equation. X square d square y dx square plus 4x dy dx plus 2y equal to log x. Okay. Now I am putting here directly the value of x square d square y dx square and x dy dx. I just discussed about it. First you have to substitute by x equal to e to the power z, and from here you will get those values. I am not repeating. Okay, so I am putting x square d square, the value of x square d square y dx square was d square y dz square minus dy dz plus 4 into the value of x dy dx was dy dz plus 2y equal to log, and the value of x is e to the power z. So this is d square y dz square plus 3 dy dz plus 2y equal to z, log e to the power z equal to z by property of logarithm. You know this. Now I will solve it. Before that, I am writing this using capital D, d square plus 3d plus 2 operating on y is equal to z, where d is equivalent to d dz, because here the dependent variable x has been substituted by e to the power z, and in this equation the independent variable is z, and d is the differential operator. So the auxiliary equation will be m square plus 3m plus 2 equal to 0. How I wrote this, you know the procedure. I am not repeating. I have discussed it about it in previous videos. Okay. So auxiliary equation is this. So the roots are m equal to -1 and -2. No, sorry. The factors will be m plus the roots will be m equal to -1 and -2. Okay. So the roots are real and unequal. Therefore the CF will be C1 e to the power minus z plus C2 e to the power minus z. Here I will substitute the value of z. The value of z is log x. So I will put this C1 e to the power minus log x plus C2 e to the power minus 2 log x. So this will be C1 into 1 by x plus C2 into 1 by x square by properties of logarithm. So this is our CF. Now I will find PI. Okay, I am removing this. Okay. PI will be 1 by d square plus 3d plus 2 operating on z. So this is a polynomial function. You know how to find the PI if there is a polynomial function in the right hand side. I am taking common 2. This will be 1 plus d square plus 3d by 2 operating on z. I am writing like this: 1 plus d square plus 3d by 2 to the power minus 1 operating on z. So half into, I am expanding this, 1 minus d square plus 3d by 2 plus dot dot dot. I am not writing more terms because you know that this function, polynomial function, can be differentiated maximum 1 times. If you differentiate it more times, then the result will be 0. So I have not written the remaining terms. So half into z minus d square of z will be 0, d of z will be 1. So this is the PI. Here I will put the value of z. Z is log x, so log x minus 3 by 2. So we got our PI. So general solution is y equal to CF plus PI, where CF was C1 by x plus C2 by x square plus PI is half into log x minus 3 by 2. So this is our general solution. This was the whole of Cauchy Euler equation. I told at the first of this video that if it may be any linear function in place of x, that is x plus a or x minus a. So procedure will be same, just this instead of x you have to substitute that function, that is x plus a or x minus a, by e to the power z. Our remaining part will be same. So you do practice this type of equation, and if you face any problem during solving, you can contact with me. Contact details of mine is given at the first of this video. Thank you.